Hey guys, it's Miss Kearney here. You are having your Kearney Math Show for the day. Today on our Kearney Math Show, we are featuring mini lesson 3, which is percent of change and percent of error. You guys know the routine. My expectations, just want to see that you are writing down everything that you see in the video. If at any point in the video you have questions, please feel free to pause, write down your question, or you can always go back and listen to it. Also, guys, this is also a really great reminder that tonight when you get home and you're working on your homework, if at any point you feel like, I don't remember how to do this stuff, please remember that you always have access to these videos. Just go back to Canvas and rewatch the video and watch Miss Kearney do some examples. That way it can help you. So take just a moment and go ahead and write at the top of your mini lesson that this is actually entry number 4. So entry number 4, and if you haven't already, you probably at some point need to go ahead and update your table of contents. So this is entry number 4. Let me update that on mine. Entry number 4. Okay? And go ahead and read your learning goals so you know what you are wanting to learn by the end of today. So by the end of today, you guys should be able to explain how to find percent of change and percent of error. So let's just, before we even dive into any of that new stuff, let's just recap what we talked about last week. Let's talk about that word percent. When you think of the word percent, remember that root word cent, that means 100. There are 100 years in a century. There are 100 legs on a centipede. There are 100. It takes 100 cents to make $1. So percent means per 100. So we're going to continue that thought today and continue to look at that percent is always out of 100. So today when you see percent, we're still going to put that over 100. Okay? So the first thing we're going to talk about today is something called percent of change. And that is exactly what it sounds like. Percent of change is the percent something increases or decreases from its original amount. So basically, it's how much it changes. It's the percent that it changes. So for example, in the real world, when you're shopping, you might find that you see a discount. Miss Kearney loves discounts. That means that's a percent of change. They take the original cost and they mark it down by a certain percentage. They say 25% off, 50% off. That's a percent of change. There's tax. That would actually be a percent of increase. They add tax onto your total bill. Also tip, that would be a percent of increase. Your bill has, when you add tip to the table, you're paying more money. That's percent increase. And one more would be markup. So usually, Miss Kearney used to work in a jewelry store. And when we would get jewelry in, it would seem like they were the best prices. But unfortunately, we couldn't sell them to our customers at that price. We had to take the price and mark it up. That way we could make some money. So that would also be a percent of change. We were making a percent of increase on that money. Okay? So for all of these percent of change problems, what you're going to use is you're going to use this proportion right here. Okay? So I want you to write this one down. This is super important. You're going to use percent. And what does percent always go over? That's right, 100. So percent over 100, and then this time what we're doing is we're trying to figure out how much did it change. So what we're trying to compare is the percentage that it changed. So we're going to talk about the difference that it changed, which is it goes with the percentage. And then if you had 100%, that was the original cost. So we're going to put the original on the bottom, okay? So percent over 100 equals difference over original. We're trying to figure out how much did it change compared to the original 100%. So let's look at an example. It says the class size went from 35 to 31 students. So the class used to have 35 students. Now it looks like some people moved away, so there are only 31 students. So we want to find the percent of change. So these are 3 really important things that you're going to want to point out. What was the original original students? What's the new amount? And then what's the difference? So when you read the problem, go back to the problem. How many did the class originally have? That's right, 35. Okay, and then now how many does the class have? The new amount is 31. Perfect. And now, by how many students did it change? So find the difference. So 35 minus 31 that means we've lost 4 students, maybe 4 students moved away. So now we're not done, we've got to find that percent. We're trying to find out what percent did it change. So we're going to use this right here that Ms. Kearney just told you about. So since we don't know the percent, what are we going to put over 100? That's right, we're going to put X over 100 equals, and now remember we're trying to compare how much did it change to the original. So the difference we said was 4. And how many students did we originally have in the class? We had 35. So now we have our proportion set up, and we're gonna solve it just like we've always solved it. Okay, so we're gonna cross multiply and divide. So grab your calculator and multiply 4 times 100, and you get 400. And then we're going to divide that by 35. And so when I put that in my calculator, I get 11.43%. Now, we also need to figure out, was it an increase or a decrease? So since we went from 35 students to 31, that was an 11.43% decrease. Or we can just draw an arrow down to show that it decreased. Okay? So just to recap, it's percent over 100 equals part over whole, okay? So for the next problem, because you have 2 examples that I'm going to get you to do on your own, okay? So for the next problem, what you're needing to do is you're needing to go through and write those things down. You're wanting to find what was the original amount, what's the new, and what's the difference, okay? And you're still going to want to do the percent over 100 equals difference over the original. Now, I'm not going to do that one for you because what I want you to do is I want you to go through and I want you to read the problem and figure out what was the original, what was the new, and what's the difference. And you find that percent of change. So after the video is off, I want you to come back and do those 2 examples, okay? So now, let's come down to, we talked about percent of change. Let's talk about percent of error. That's exactly what it sounds like. What does it mean when you make an error? That's right, you've done something wrong. So a lot of times we can figure out the percent of error of how much we made a mistake. So for example, if you read the definition of percent of error, it says it's the percent that is estimated quantity differs from the actual amount. So for example, when you are watching the news, does the weatherman always get the weather right? No. So probably there's some room in there that they made an error. So we can figure out by what percentage were they off. They said it was going to be 70 degrees today, and it was actually only 62 degrees. By what percent was there an error? Also, measurement. Sometimes when you're measuring things, for example, when I look at a potato chip bag and it looks super full, I look at the bottom and it says it has a certain measurement. But really, the measurement on the inside might not be quite right because there might be a lot of air in the bag. So sometimes there's an error there, percent of error with the measurement. Or anytime you estimate. For example, if I say that I'm going to estimate that there's going to be 300 people at the dance, but instead 400 people show up, there's a percent of error. We got to figure out by what percent was that off. Okay? So let's look at how this works. We're going to do it very similar to what we just did. Okay? So we're still going to put percent over. What does percent always go over? That's right, 100. And then we're going to set that equal to, and on the top this time, we're still going to put the difference because we're comparing how much were we wrong to what we're trying to do is we're comparing it to what the original prediction was, okay? So we're going to put still original, but when we put down here, we're going to put original prediction. So we're trying to figure out how much we were wrong compared to what we originally thought. So for example, it says you estimated, I'm reading this example right here, you estimated 200 people attended a school dance. The actual attendance was 240, so more people came. What is the percent of error? So what did you originally predict? We're still going to put that predicted original just like we did above. That means we had 200 people. Well, how many actually showed up? So that's kind of like my new amount that we talked about earlier. So 240. And then that means that the difference is 40. That means we were 40 off. Okay? So now let's set it up. We don't know the percent, so we're still going to put percent over 100. And then we're trying to compare the amount that we were wrong. So we were off by 40 students. So we're going to put the difference on the top, and we're going to compare that to what we originally thought. We originally thought that 200 students were going to come. So we were off by 40 to the original 200 that we thought. And then you're going to solve it just like you guys are rock stars at solving. Cross multiply 40 times 100. And then divide. And when I do that, using your calculator, you can check behind me. I got 20%. And it was actually an increase than what I thought because it went from 200 to 240. So it was a 20% increase error. Okay? So now what I want you to do is I'm getting ready to stop the video, but you've got several examples you need to go back to, okay? You got 2 examples at the top and 2 more underneath where we just worked. So what I want you to do is go back and look exactly how I set the others up, and now you try it on your own. If you need to ask for help from someone, that's fine. Make a note of any questions that you have so you can ask me when you come to me, okay? Great job today, guys. I can't wait to see all the problems that you have done when you come to my station. And remember, at any point tonight during your homework, if you have questions, feel free to go back and watch the video again. So that concludes our episode of the Kearney Math Show. Thank you all for tuning in, and we hope to see you on the next episode. Peace out, Rainbow Trout. Love you, mean it. XOXO.